This is the recorded lecture for Chapter 5, and we're going to discuss information technology and public health. This is for the information technology for health professionals. When we really look at information technology and public health, it's really changed how we look at disease, identifying diseases and following diseases and tracking diseases and causal effects and such. What used to happen manually now can be done in a much more efficient, much speedier methodology. For instance, trailing down diseases that kick up. For instance, we can not only identify the bacteria causing the disease, but we can do a genotype of that and track that bacteria back to its origin, if you will. And that allows us to solve disease problems and overcome potential long-term chronic disease areas, if you will, in a much more efficient way. So information technology has really changed how public health works, and that's an important thing to understand as we move forward. So public health is an area of our health system that deals with the health of the whole community. In fact, its goal is to deal with those kind of problems that can be that deal with the public as a whole. For instance, cholera due to insufficient disposal of waste products or contamination of drinking water. All those things add on to that, and public health deals with that, and they track diseases as well. They can save more lives than actual direct medicine, in fact, because they understand the causal effect, the epidemiology of the disease. They can lead to the prevention of that by providing a cleaner, a healthier environment, like taking steps against global warming, providing better sanitation, distributing preventive healthcare information to the population, and the development of vaccines. So public health is a really important facet of eliminating those diseases that have plagued man throughout history. The field of public health also includes the anti-tobacco, not the use of tobacco, but the elimination of tobacco use, and then planning for natural disaster as well as human-made disasters, forest fires, those kind of things, planning for natural disasters, earthquakes, and such. And they can also identify and contain epidemics, which is a regional disease that affects everybody in a certain region, or pan-epidemics, which could be epidemics which are in more than one place. So they play an important part in that. Now, public measures like decent sanitation can also affect the spread of disease. And like I said, one of the major causes of cholera in the United States in the 1800s was people would put their outhouses in proximity to their wells. And so they would dig a hole for their outhouse, and it would seep into the ground and move to their water table, and they would be drinking basically the sewer water. And that would spread the cholera. By just moving the outhouse, separating the outhouse well to a reasonable degree, they can eliminate a lot of what went on. And so just simple hygienes, washing your hands, if you will, after going to the bathroom, all those kind of things are part of public health. Now, this is a poster from 1918 looking at influenza, and it says, the handkerchief, and it's use a handkerchief and do your bit to protect me. And so what they were trying to do was to block, when people could cough or sneeze, they would sneeze, everybody else would catch it. So what they would do is they would use that to block their sneeze, or the effect of their sneeze to their cough. And so they felt that would help colds, influenza, pneumonia, and maybe even tuberculosis from being spread. So that was one of the first big steps in that. There's social inequity in health, and that is that social inequity is one of the determinants of health. And that is, there's a diminishing inequity within society thanks to public health, because public health focuses on everybody, and is not focused on the higher socioeconomic people. In fact, it tends to focus more on the needy people, doesn't matter whether their socioeconomic disparity of race, color, creed, economics, or whatever. Now, the social inequity in health, we follow that. According to data from the Congressional Budget Office, inequity continues to grow, which is kind of important in a sense. Between 1979 and 2007 in the United States, the income gap between the top 1% and the middle and the poorest fifth of the population actually tripled. So the gap became much larger. We can think a lot of reasons for that, depending on which political rhetoric you would want to believe. So this looks at the percent change in after-tax income, and you see that there's the top 1%. Look how much they have risen, and that you see middle class, which has risen plus 95%, but look at the lower end of this, the middle and bottom, the middle fifth and bottom. We're starting to see they didn't really change much at all as compared to that. But what happened is because of this increase, the cost of goods has increased in proximity to that, and yet the revenue, the after-tax income for the lower middle class and bottom, the poverty level middle class, I'm sorry, the poverty in the lower middle class has not increased at all, and you can see that where that's starting to occur. Now, as the incomes at the top continue to grow, the number of people in poverty, the percent of the population in poverty also grows. It becomes a world of have and have-nots, and we're seeing that now in our society. According to the Census Bureau, in 2008, there were 39.8 million people in the poverty, 13.2%. And that's an important number. In 2009, that increased to 43.6 million. Think about that. 43.6 million people in the United States are living below the poverty line. That means they make less than $21,154 for a family of 4. That's extraordinary. How one lives on that is just interesting. When you think about just trying to find a place to live, for instance, that would pay for that. If you think about just finding a house or an apartment or someplace for a family of 4 to live, it would cost you in many places $700 or $800 or more. So at $800 a month, that would be $9,600. So half of what you make basically goes to just a place to live. Forget the utilities and forget food and anything else. That's just what you live on. And so there was a time when $20,000 would service a family of 4, but because the cost of living has gone up significantly to match the top 1% and the top middle class, we're starting to see that's not true anymore. In 2009, more people were poor than in any previous year for which data is available. So we have the largest subset of poor people below the poverty level that we've ever had in the history of the United States. That's really interesting. In 2011, the U.S. Centers for Disease Control, CDC, published a report on health disparities and inequality, and they stated that a health disparity is a particular type of health difference that's closely linked with social, economic, and or environmental disadvantage, and that's according to the Health and Human Services Department. The CDC found that the data pertaining to inequities in income, morbidity, that would be injury, mortality, death, and self-reported healthy days highlight the considerable and persistent gaps between the healthiest persons and the states and the least healthy, So basically, that change in economics is causing a change in health equality. The correlation between poor health and inequality at the state level holds at all levels of income. So this is consistent. This is a direct result. The higher incomes have better health than the people with lower incomes. On April 8, 2011, the Health and Human Services announced that it was launching 2 strategic plans aimed at reducing health disparities among racial and ethnic minorities. Now, if you've listened to my previous lectures, this is not new news. We've done it several times. We've launched these new objectives. Problem is they haven't reached fruition or success in many cases. Among the steps to be taken are increasing access and expanding insurance coverage. And if you go back to Obamacare, that's one of the driving forces of doing that. They suggest recruiting personnel from underserved areas for careers in public health and training community health workers. So taking people from the economic status, educating them, and then sending them back to help improve the health care, the health equality in those areas. And then efforts to target cardiovascular disease, childhood obesity, smoking, maternal and child health, and flu and asthma. And by the way, maternal health, it's interesting, maternal child health. Maternal health is interesting that if we spend the dollars in preventive health, prenatal visits and vitamins and things like that, the money we have to spend later on premature infants and infants born with malnutrition and on and on and on will decrease significantly. So the money we save from the infants that don't need high risk and high level care on birth, we save by paying for this prenatal care. almost nobody who does this budget understands that. In that one pays for the other. So if they eliminate that, that's better. We go to cardiovascular disease. We can convince people to not smoke and to have good cardiac health. Then the dollars we save in cardiac events comes back and pays for the preventive health and training, and on and on. So getting your flu shot. Getting a flu shot and pay for the flu shot saves the cost of people who have the flu, both in medication and support. And it goes on and on and on. As the preventive health makes a difference. If you go back to 1994, when the Clinton administration suggested a single-payer system in the United States that didn't go through, you'll find that the state of Oregon put that in place, the Oregon referendum, and they really put the what Clinton's presented in that process, and they put it in place, and they moved a lot of their money into the preventive health. And they were very, very efficient. They didn't pay for multi-organ transplants. They took the money and used it for cardiac training and cardiac prevention, cardiac event prevention. They moved to prenatal care for women, on and on and on. And they actually saved over $50 million a year in providing Medicaid and S-CHIPs, which is the health care for children. They saved over $50 million a year by just doing those steps, and they provided better care for their population. Now that's been eroded over time politically, because as different people came into politics, they eroded that money, not seeing the benefits. So among the steps to be taken are improving health data collection and outcomes research, so we can identify what works and what doesn't, and whether we're actually creating outcome changes. Evaluating the progress made towards meeting these goals. And the problem with this is that these budgets that are set up are always subject to change from one year to the next, and often they get extravasated. That means to be deleted or reduced significantly as certain people review them. Now, public health informatics is another piece of public health, and it supports public health practice and research with information technology. We can follow diseases and their incidences from one area to the other, and there's all sorts of things we follow. They follow like chronic diseases like cholera, TB, those kind of things, but also sexually transmitted diseases, environmental diseases like Lyme disease and Rocky Mountain spotted fever, and those kind of things. Epidemiology is the study of disease by collecting and analyzing statistical data, what causes it and what perpetuates it, how it's communicated. And computerization, I'll say technology, is helpful in collecting and organizing worldwide data, and that worldwide data is collected by an organization called WHO, the World Health Organization, WHO, and they tend to do what our public health does in the United States. Our Department of Public Health in the United States is really a facet of the World Health Organization, and all the public health agencies or departments for all the countries that have one feed that information to the World Health Organization. Now, IT plays a role in infection control because it helps with surveillance, monitoring of diseases and reporting the spread of disease, and identifying organisms and spotting trends. So it helps to identify those very early. What used to happen is by the time we found out what caused the disease had run its course, and so we didn't really change anything. Nowadays, we can minimize the effect of an outbreak and find the cause of the disease. And so by finding the cause, we can determine the treatment for the people that have the disease. We can identify preventive measures to stop other people from getting the disease, and we can stop the causal reason that people are getting the disease in the first place. So we identify an epidemic means counting the extra cases. We look at all the cases involved. Excuse me. Computers are able to do what's called computer modeling of how a disease can spread based on multiple factors. If you watch any of the movies about the spread of diseases and all these, the zombie apocalypse and all that, you'll see that they can use computer modeling to determine how fast the disease will spread, and they can determine what their timeline is. And they can prepare the what-if simulation with changing variables, wind change or different population or the virality of the disease, and then using computational models. Before computers or any understanding of the germ theory, statistics, and public health measures stopped the epidemics. The gender, the smallpox, and the treatment for smallpox. We looked at Dr. Snow and cholera, how we could stop those, and so everything was developing preventive health care, but we really couldn't do much as far as stopping the epidemics in a timely manner. For instance, the Spanish flu epidemic, or pandemic, and that means it was worldwide, from 1918 to 1919, public health measures had a little effect, except that it was the first time that we responded to diseases in the United States, and we used quarantines and those kind of treatments. So we actually had a nationwide referendum on helping to prevent the spread of the Spanish flu in the 1918-1919. That was influenza. We called it Spanish flu, but it was really an influenza disease. Now, public health today, contagious diseases have reappeared in the late 20th and early 21st century, polio and measles, due to failure to vaccinate children by choice. Now, I'm going to put a little editorial in here, and that is there's been a lot of talk about vaccinations causing one thing or another, and the major one is autism. There have been 23 studies done in 16 countries, and these are studies that were not funded by the pharmaceutical companies or people that made vaccines. So these are privately funded studies, 23, 16 countries, over 100,000 children were identified. Now, with all of that, they looked. Remember, every country has a different schedule for vaccines, so it doesn't have. They looked at all combinations of vaccines because we give a lot of vaccines at one time sometimes for children and their child immunizations. And they looked at all of that, and they could find not one single case caused by vaccines of autism. Not one single case. 100,000 children. 23 studies done by pharmaceutical companies, because there are more done by pharmaceutical companies in 16 countries. That's really interesting. So the idea of vaccinations causing autism has never been shown in a data-based study. There was one study that was false in a sense that suggested that it found that, but it has been disproven. So that single study is what a lot of people go to when they talk about non-vaccinating their children. The other interesting thing is that they did find a link to autism, and that is to the new computer video games. That a high use of video games would cause an overstimulation of the brain and could perpetuate the effect of autism. So the truth is, if you wanted to limit a potential for autism in your children, you would limit their access to video games. Now, I don't see anybody standing outside of the GameStop and boycotting PS1, whatever it is now, and Xbox and all that stuff. So it's really interesting that we have focused on the vaccine issue, but really we know we have some known causes. Now, we have new diseases that continue to appear and challenge our public health authorities, and a lot of them are based on viruses now, not bacteria. AIDS, SARS, and West Nile virus are those things that are really affecting public health. Now, you won't get AIDS from hide and seek, so to speak, and that's really interesting. It's really a way to look at AIDS, because when AIDS first was identified, people were worried that they could touch somebody and just get it. And clearly we've gotten smarter and have a better understanding of what is HIV, which can develop AIDS. You don't get AIDS from a public pool, and strangely enough, that chlorine is a very good destroyer of the AIDS virus. You don't get AIDS in a restaurant. If somebody cooks your food that has HIV, doesn't mean you'll get HIV. In fact, your chances of getting HIV in a restaurant are less than 10% of you going to the bathroom and getting AIDS in a toilet, which is 0.00000, 10 zeros, 1%. We also have some issues in the world today. We have MRSA, methicillin-resistant Staph aureus. We have CRKP, NDM1. We'll talk about those. So we have resistance that we've created. Now, MRSA is an interesting disease in the sense that the Staph aureus, and we have grown this. This is a product of our idiocy, in that we have ineffectively used antibiotics to treat Staph aureus, and we have helped it develop resistance. We have grown this like a flower in our garden, and mankind has created MRSA. And now MRSA is becoming more and more and more resistant. In fact, even some of the medications that we're using now are starting to show a beginning of resistance. Public health also looks for vector-borne diseases, and vector-borne diseases transmitted to humans or animals hosted by a tick or mosquito or another arthropod that carries a bacterial virus. And according to CDC, vector-borne diseases are emerging and re-emerging. Some examples are malaria, yellow fever, West Nile virus, on and on. And you see that if flies still are important with spreading disease, and limiting them is important. We now know what flies eat your food, they carry diseases, but there were times in past and early 1800s that people would just eat rotted meat, with maggots in it, if you will. So as soon as information technology to combat 21st century epidemic, our cholera that has plagued mankind since the beginning of people living together. In October 2010, the epidemic cholera in Haiti began drawing the attention of public health workers. Information technology has played a big part in trying to combat the epidemic, so public health officials are using text messages and radio to warn the population of health risks, teaching them again not that cholera is a fecal to oral disease. That means you have to eat the poop from somebody who has cholera. That sounds gross, but that's essentially what happens. And so it's a fecal to oral disease, and that perpetuates that event. So limiting that is important, obviously. So information technology has played a big part in trying to combat the epidemic. Cell phones are being used to track the spread of disease, and because cell phones can be used to monitor a person's movements, for example, we could do a history of where they've been from the areas of cholera to areas without. Predictions of new outbreaks are possible. So we can start to predetermine where we might see a cholera epidemic in the future. ONCHIT, we identified that before, as Office of the National Coordinator for Health Information Technology. It proposes a national interoperable network to gather and disseminate information, one that everybody has access to, all the public health and World Health Organizations. There's also the National Electronic Disease Surveillance System, NADSS. It's part of the Public Health Information Network, and it's a national electronic surveillance system which allows us to follow, predict, and manage epidemics, which is a fairly nice step as we move forward. So the electronics and the technology is starting to help us do that. Now, some of the software tools we have, MIDAS is a U.S.-funded plan for researchers to use computers to model diseases, and MIDAS has become a very important piece in that. WHONet, World Health Organization net, if you read that, is a microbiology information system which is used to monitor antibacterial resistance to map and predict disease spread. So MIDAS is a U.S.-based software primarily. WHONet is a world software used by the World Health Organization. Now, we also look at climate change in the world of public health, and the Earth is warming. We know that. No matter what you would read politically, the scientific data shows the world is warming as we go forward. And we don't really, a lot of people don't really understand what that translates to, and they think that if they've had a cold winter, then the world is okay. That's not true when you look at that. So in 2011, Dr. George Benjamin, head of the American Public Health Association, stated, "The science is unequivocal that global warming is occurring and that human activity is the cause of that. We are causing that effect. Global warming is caused by humans. We are doing it." And so it will continue until such time as the global warming makes the Earth uninhabitable at some point in time. Now, human activity is helping to make it happen by adding more heat-trapping gases, primarily carbon dioxide, into the atmosphere. That's through our industry, as well as our cars and all the motorized vehicles we have using fossil fuels. According to the head of the American Medical Association, extreme winter conditions and summer heat waves are both dangerous to our health. What we're seeing now is massive storms that didn't happen before. And I say massive storms, we can have tornadoes and hurricanes in seasons we never had them before. We get a massive wind that's at a much, almost a torrential wind storms that we're seeing, and they're starting to increase. And so there's been an increase in insect-borne diseases because of that, because insects are no longer limited by the seasons. Over 30 years of asthma and allergy seasons have been extended by 20 days. So we're really seeing is the diseases that we have are getting worse. And because the air is becoming infected or becoming tainted, we're starting to see people with asthma and allergies start to increase in the symptoms, and the number of people with allergies and asthma is increasing exponentially. NASA says there's a 30-year warming trend. Earth is the warmest it's been in 12,000 years. We have a color-coded map in the next slide which shows the surface temperatures from 1880 to 2005, the warmest year on record. Dark blue is the greatest warming, dark red is the greatest warming, dark blue is the greatest cooling. And what you're seeing is we're seeing this increase in heat across this, and the color-coded map shows an average temperature from 2001 to 2005 compared to the base period of temperatures from 1951 to 1980. So the dark red indicates the greatest warming, and purple indicates the greatest cooling. So what you're seeing here is we're seeing a strong warming trend that has occurred in that period of time. It's irrefutable. Now, global warming may have a devastating effect on human health and life, including more intense heat waves, including more heat-related deaths, an increase in asthma and eczema in children, and what they don't talk about is a greater release of methane gases from the underground areas, and primarily under the ocean. As the oceans heat, they will release more methane gas, and more methane in the air means we don't breathe oxygen anymore, and that's a problem, obviously, for any oxygen-breathing organism. Global warming may have a devastating effect on human health and life, including more intense storms, which we're already seeing. Flooding of major rivers is increasing. We see that. Increased pollution, drought, and forest fires. We're seeing that. The destruction of crops and the destruction of wildlife habitats based on this global warming. So this is going to cause a lower food resource, less food, increased pollution, drought, forest fires, and onward. Now, what can we do? We looked at this dilemma, and it looks pretty terrible. One of the concrete steps that we can do is to slow the warming by cutting carbon dioxide emissions. And that means, however, the emissions from U.S. businesses continue to grow. There's an annual increase by the S&P 100 of 0.36%. So that doesn't sound like much, but right now we're on the precipice of tilting. There's called a tipping phenomenon. That means we get at such a point we can never get it back. So once you tip and you cause this event, it will be perpetuated. We can't fix it after that. And so we're that close, so 0.36% is pretty darn important. Hurricane Katrina, New Orleans flooded both because it was a monster hurricane and because the levees failed. So not only that the hurricane came in, but the levees failed because they were antiquated. They had been built 200 or 300 years before. So Katrina is a good example of what we're going to start to see. Computers can be used to model various hurricanes, their paths and effects, and we're starting to be able to be more predictive of that now. In 2004, in an exercise of simulating a direct hit by a slow-moving Category 3 hurricane using two different models, both models showed that the levees would not prevent flooding in New Orleans. So we knew that in 2004 then, but when Hurricane Katrina occurred, Hurricane Katrina occurred, we ignored it, basically, is what we're saying. And this looks at Hurricane Katrina base map. We see its trajectory as it came on land in the United States. An adequate public health plan could have been in place before the storm. We could have better evacuation plans, which we didn't have. The FEMA would have been more proactive. The designation of shelters provided with adequate food, clean water, medications, vaccinations. There were terrible events that occurred in New Orleans because of Katrina. There was looting, and there was an increase in crime and increase in crime against individuals and such. So plans to get all the people to those shelters, plans to clean up and rebuild the city, those could have been in place, but were not. In fact, they're still rebuilding. After the hurricane, many people were stranded without basic human necessities, and they were exposed to human waste and toxins and physical violence by gangs and people that banded together to get there, so to speak. Many shelters didn't have electricity or air conditioning in the middle of the heat. And 10 years after Katrina, New Orleans population is 29% smaller than it was in 2000. So people were evacuated to different parts of the country just so they could survive. This is a good look at Katrina. The area of Katrina flooded, if you will, and everything is really underwater. All that is ruined, and once the water level goes down, you start to develop a mold. So these had to be destroyed, and environmental agencies had to come in and eradicate the mold so that people could live there again. This is another look at Katrina. Homes in the North Ward of New Orleans after Katrina. You see they're just piles of trash, like a bomb had hit. Now, BP Deepwater horizon spill, that's interesting. BP on April 20th, 2010, the BP Deepwater Horizon oil rig exploded in the Gulf of Mexico, and it killed 11 people. But among the first effects was a spill of tens of thousands of barrels of oil a day into the Gulf. Now, we don't know exactly how much because BP has not ever brought that forward. It effectively polluted the water, damaged the shoreline and wildlife. So the second hit here was the Gulf of Mexico had this environmental spill. According to the Journal of the American Medical Association, JAMA, the oil spill in the Gulf of Mexico poses direct threats to human health from inhalation or dermal contact with the oil and dispersant chemicals, and indirect threats to seafood safety and mental health. So this spill had far-reaching effects, not only locally, but in the environment. This is a close-up of the weathered emulsified oil that's located on the Grand Isle, Louisiana. So the second effect was this oil and its sticky, nasty, tarry type substance. NOAA, the National Oceanic and Atmospheric Administration, used computer models to predict what coastal regions would be affected by the oil spill, so they were at least be predictive. The government and common media interpretation of the National Incident report released in August that only 25% of the oil remained is disputed by many scientists who maintain that 10% is gone, either skimmed from the surface or burned, and 90% remains dispersed, dissolved, or residual, and that is dangerous in all of these forms. So the government release, the National Incident report, if you will, says that 25% only remains, but the scientific community says it's probably closer to 90%. Now, the earthquake, the tsunami, and the radiation disaster in Japan. On March 11, 2011, a 9.0 magnitude earthquake, which is gigantic, hit Japan, followed by a tsunami with 30-foot waves. And the NOAA used computer modeling to track the tsunami in real time so they could predict and help to evacuate people. In March, the statistics, though incomplete, were frightening. More than 10,000 people were dead, almost 18,000 people were missing, 390,000 people were displaced and homeless, and 118,000 buildings were damaged based on this tsunami. This is the model of the Center of Tsunami Research at the NOAA Pacific Marine Environmental Laboratory, which shows the expected waves that are going to be created as it travels across the Pacific Basin. Very interesting how they can now track that. Now, the earthquake and tsunami destroyed the cooling systems of several nuclear reactors, triggering explosions and fires, and releasing the radiation material, sparking global fears of a widening disaster. And in Japan, people were evacuated first from a 12-mile radius, and later 19 miles was recommended. Now, we think of the atomic bombs that were released on Hiroshima and Nagasaki. This effect that we see at this point was fairly equal to that event. And I say fairly equal, caused as much damage as those atom bombs. So you have to really understand the dynamics. Drinking water and the farms in the area were totally contaminated. And much of the food for Japan came from that area. By April 4, 2011, radiation was found in the water of more than a dozen U.S. cities, in the air and rain on the West Coast, and in milk in Vermont, Phoenix, and Los Angeles. Now, most of that contamination is below EP standards for exposure, but it did increase based on a tsunami and radiation disaster in Japan. Interesting to think how that affects worldwide health. So in summary, public health involves the protection of the health of the whole population. Epidemics, which could be international, and I think of epidemics as being in one area, region, and pan-epidemics being in multi-areas, also requires world cooperation and is usually managed by the World Health Organization. Global warming requires a global response by all industrialized nations. The GD6, which is the top 6 industrial nations in the world, have agreed that it's important. Unfortunately, the United States doesn't want to. The United States cannot get itself together, say it a different way, I guess, and respond to that. And we're one of the biggest abusers. Computers can model diseases and natural disasters so that adequate public health responses are in place before disaster strikes. We can model it, but if the government does not choose to put in preventive planning and resources, then it's of no use. So we've looked at, in this chapter, we've looked at really the total effect of public health and some of the disasters and their responses. Thank you very much.